Hi, I'm Jean-Marc Prieur, a program manager on the Visual Studio team. In this video, I'm going to show you how you can benefit from the integration of Team Foundation Server and Visual Studio Team Services with SonarCube to manage your technical debt. I'll also show how you can leverage new features in Visual Studio 2015 Update 1 to stop new static analysis issues from appearing and reduce the debt as you code. I'm going to begin with a quick review of technical debt and why you care. Then I'll briefly present SonarCube. I'll start by a demo on how you can quickly add a SonarCube analysis to your continuous integration builds and what benefit you can get from it in your team. Then I'll also show how you can benefit from the new baseline and error list filtering experiences in Visual Studio 2015 Update 1 to stop the technical debt from increasing and even clean it up as you make changes. Finally, I'll share with you a few pointers to resources that will help you to dig in further. So what is technical debt? And why do you care? Technical debt is a set of problems in the development effort that make forward progress on customer value inefficient. Here, you can see some symptoms and causes of technical debt. Technical debt saps productivity by making code hard to understand, fragile, difficult to validate, and it creates unplanned work that blocks progress. Technical debt is insidious. It starts small and grows over time through rushed changes, lack of context, and lack of discipline. Organizations often find that more than 50% of their capacity is sapped by technical debt. For developers, Visual Studio provides some tools to identify your debt, mainly for managed code. For example, CodeMap helps finding architecture spaghetti. CodeMetrics shows code complexity. Static analyzers detect weak programming conventions, security issues, and so on. But if your code is not managed code, or if you want to have a higher level view and a common definition of the quality for your whole organization, then you should have a look at SonarCube. SonarCube is a popular open source solution. It supports analyzing code from many languages, computing metrics, and displaying quality indicators in a portal. I have added a screen copy of nemo.sonarcube.org, which is a site where you can look at the quality of open source projects. Microsoft have been partnering with SonarSource, the company producing SonarCube, to provide integration between SonarCube and MS Build, Team Foundation Server, VSTS. You can therefore benefit from the best of both worlds. In my first demo, I'm going to show how to set up a continuous integration build in Visual Studio Team Services and perform analysis of code on build and send result of analysis and test to a SonarCube server hosted in a VM in Azure, but that could be on-premise. Let's start by looking at the app I'm going to analyze in Visual Studio. So here we are in the Visual Studio solution, and as you can see, there are lots of warnings, which is one of the indicators of technical debt. The first step is to understand our technical debt, measure it, and understand the trends in order to be able to manage it. So for this solution, I had set up a continuous integration build, and here we are in Visual Studio Team Services, but that would also be the case in TFS. I've also set up a SonarCube installation. It's in a virtual machine in Azure here, but that could be on-premise. I've modified the build definition to add SonarCube analysis by adding these two tasks. This is very simple. The first task needs to be done before MS Build. The second task, the end analysis, should be done after running MS Test. The initial task is configured to point to the SonarCube URL and credentials, so that's the endpoint. But I also gave the project key, the SonarCube project key, which is a unique identifier, a name for this SonarCube project, and a version. I have already done a build, so we can have a look at the build results. And you see that if you know team build already, there is a new section, SonarCube Analysis Reports. And when you click on the link, you get directly to the SonarCube project itself, where you can have some information about how many issues you have and their severities, an estimation of the time it would take to remove them, remediate the debt, and all kinds of interesting metrics about your code base, including complexity and duplications. You have a summary, which is a kind of rating and the percentage of that in your application. Even better, you can do a diff with respect to a baseline, and you can see how your technical debt evolved. Here we see that this code has made progress. So in this demo, you've seen how you can quickly modify your continuous integration build to support SonarCube analysis and measure your technical debt. By the way, that also works for Java if you use the Maven task in team build. Back to our solution in Visual Studio. Let's control the debt. Let's be back in our Visual Studio solution. We know that we have a lot of issues, and indeed that would be the case for almost any existing code. Have you noticed that when you start a new project, you tend to pay more attention to the warnings and even try not to have any? But for existing solutions, that is not possible. As I type, the Rosling analyzers will tell me that I have new issues, but they will be hidden in the middle of the existing issues. Therefore, let's acknowledge that we have technical debt and let's take a fresh start. For that, let me use a new command in Visual Studio, which is analyze, run code analysis, and suppress active issues. So I'm going to run this command, which I could have run only on one project using the Analyze menu, or even also from the Analyze top level menu, where you have exactly the same kind of command for both level, the solution, and the project. What you see is that a build has started. Now the build has finished, and something that has happened to remove all the issues, actually to take a baseline. And you see that some new files have appeared, the global suppression files, and they contain suppression messages, and especially they are very special because the justification is pending. That's telling you that we have taken a baseline. And now, when I will write code, and let's do it here, let's do something simple. I will just mimic as if I had written code. I will see the warnings appearing, and I can clean them up immediately. So in that case, let's assume I've written some code and I've left some assign but not choose variable. I can immediately clean it because it's no longer polluted by all kinds of warnings. So I understand that I can keep the code clean. I can not increase the technical debt. But we can do better. We can clean up the code as we go. For this, we have introduced a new filter in our list named Changed Document. And what that means is if I apply this filter Change Document and use, and you see this new column suppress state that shows me all the suppression. If I now show the suppression, what I will see is all the errors, all the technical debt issues, which I have the opportunity of fixing as I'm developing, as I'm changing this code, for example, to fix a bug or to develop a new feature. And if you have fixers, you can apply them. Otherwise, you just do what is advised by these warnings, by the Rosling analyzers, and quickly you get your debt down. So now I'll commit the changes, I'll sync, the continuous integration will happen, and when the build is completed, I will be able to see in SonarCube that the technical debt has decreased. So we've seen how in the IDE you can stop new static analysis issues from appearing and start making a dent in the technical debt. With SonarCube, you get the big picture and you can control the definition of the quality, that is the bar, for your organization. So that's it for the demos. I hope you found them useful. To conclude, here are some resources you can follow to find more information. Thanks for watching and have a nice day.